So this morning we're going to be taking a Kubernetes cluster. This is going to be a private one, and we're going to expose a number of HTTP services from there to the internet. We will not expose the cluster, so we don't have to worry about locking it down or any specific security settings. We're just going to take, in this instance, Keycloak and Grafana, the two of them, and expose them on the internet. Now, the tutorial is on the Inlets blog, and we're largely going to be copying the instructions, so I'm really just guiding you through it. And if you want to go and try this yourself, you can go ahead and look at the tutorial. So this is the blog post, and we will use an EC2 instance with an inlet tunnel server set up on it. That is how we get the public accessibility. We'll then create two DNS records that map to it. We'll start the inlets tunnel server on there, we install it with systemd. Now that can be done through automation or cloud init, but we'll do it manually so that you can understand exactly what's going on. Over within the Kubernetes cluster that we create, we're going to install Grafana, and we'll also install Keycloak. Now those will be exposed via the internet through those subdomains that we'll create. So you will need a DNS domain, and you'll need to be able to manage it. You'll need an EC2, access to EC2 on AWS. A Kubernetes cluster, now this could be on your home lab, your Raspberry Pi, it could be a customer's on-premises environment, up to you. And then I'm going to use Arcade to install some of this software, and you can of course use whatever you like, for instance Brew or Helm. The first step really involves creating the server, the EC2 instance, that's going to allow the traffic to pass in and out. We have port 22, and this is going to be used just for our initial installation. You could always disable that afterwards. Port 80 is used for Let's Encrypt, and that is how we obtain a certificate. After that, it's not used. 443 serves traffic on the domains, and 8123 is the TLS port that the Inlets client will use to connect to this server. So this is what it would look like if you were to create the security group ahead of time. What I've actually found is it's a bit easier if you launch an instance and then edit afterwards. So we'll call this inlets Kate's, for instance. I tend to find Ubuntu is probably the easier one to use here. Now I should still have the key from last time I ran through this for the blog. We'll create a new security group, and we'll just allow HTTPS, that's 443, and 80 on all IP addresses. Now you could of course create an IP whitelist. You could prevent certain ones from accessing that. And then let's go in and find the security group, because we do need the extra port for the control plane. Now this is usually under security. Okay, so we have HTTP 443 22. We just need one more. That's for the inlets TCP control plane. As I say, you could set this to only come from to only allow incoming from the egress IP of your private cluster. That would be fine as well. Okay, so we have everything that we need. We're back to the blog post, and now it's telling us we need to create DNS records. Okay. Now in this case, I think I created a CNAME against the DNS record that we got back. We can also just go against the public IP addresses if we want to, and that is on the console over here. I'm using the DigitalOcean as where I'm managing this domain. I may have to open the UI to do this. And we wanted Keycloak dot we'll put, see if we're allowed to create any more. Right, so I'm gonna have to log into the DigitalOcean UI for this instead. And networking domains. Okay, so managing this 06SIO domain here. Yeah, I guess we could edit the records that I was using previously. The main idea here is that this IP address or the public DNS that you get allocated to these needs to map to the domains that we're going to be using. This has a TTL of 60 seconds, deliberately quite short. So I'm just updating these records. And what we want to see, this ends in 195, is that when we resolve them, that they end up coming back from 195. In this instance, that was very, very quick. Perhaps it hadn't been resolved recently. And again, both of these are now resolving as we want. Next step is to connect with SSH. So I believe, is it a PEM? Yeah, this is the one we want. So SSH, and we should have a command. It's a lowercase I for the key, and then we need to put the address. So in our instance, we've got the address here, and the user is Ubuntu, right, rather than root, for instance, as you may have on some of these instances. So we're now in, and we could probably try an NSLOOKUP on here as well. Interesting. Let's try and log in again. Right, so Keycloak inlets 06SIO. 06S would be OpenFAS, and as you can see, that's resolving to the address that we want. Great. Okay, what's next? Next, we're going to install inlets. The easiest way to do this is to use my arcade tool. This is a bit like Brew, just a lot faster, as you can see. We've moved the inlets pro binary in place, and now we can see the various ways that we can start HTTP tunnels, TCP tunnels, etc., etc. We're going to go ahead and generate a token. Now we have this script, and I've made this so that we can copy and paste it quite easily. So Keycloak inlets 06SIO, domain 1, domain 2 is Grafana. And of course you can expose various other things as well yourself. You just decide what you want. And the email is for Let's Encrypt itself. Now, when I run this command, this would normally run the server directly, but I've added generate systemd to actually get a systemd unit file, because we want to install the service on the server so that it restarts on its own. Okay. Let's copy it into the systemd location. We'll enable it and start it. And in this case, I also want to be prepared to stop the server if needed, because it's going to Let's Encrypt, trying to obtain a certificate, and you can get rate limited if the DNS isn't properly propagated. But in this case, it's actually worked perfectly. Both of our addresses are now decorated with TLS, and these messages are where someone's trying to access the HTTPS port without a domain, so people are just probing. This is what we want, and right now we should see if we access HTTPS 503, so there's no upstream, but that is a valid TLS certificate that will open in the browser. So we've configured the server. Everything we need is on there. The systemd unit is installed, and now what we want to do is create a cluster or expose a local cluster. So I'm going to get, in this case, kind and kubectl. I'm going to install them. Kind is a pretty quick way of running Kubernetes locally. It uses Docker, It runs the control plane within it. If you have a Raspberry Pi, you could just run K3s there. This takes a couple of moments. It's very quick actually. And then we could just make sure that we're in the right context, just so that we don't expose something from a different cluster. Now what we're going to do is use Arcade to install the Grafana Helm chart. We could go ahead and port forward that and access Grafana, but we don't need to because we're going to put it on the internet. Now we'll do Keycloak, and Keycloak, the sample, is a password of admin. We definitely don't want that. So we generate a new password using the same command we used to get the token for the tunnel server. I'm then going to create a YAML file. You'll see the token password is put inside of that. And we'll then apply the Keycloak. So the next command is going to show us that we have cluster IPs, which is a kind of private address. These are not yet accessible on the internet, but we're getting really, really close now. We now want to configure the inlets client. So we're going to put in here the public IP. And it also wants us to add the two domains. So the first one is the Keycloak domain. Okay, I haven't got this straight. I'll do this again. Inlets, and domain 2 is Grafana. The token. We need to copy the token from the server so that we've got it locally. Now I don't know if I already explained it, but there is some tooling that does all of this for you end to end. One of the tools is inlets CTL, and as you run that, it creates the EC2 instance. It gets the password and injects it in, and then it's also available on the client. Everything's done for you, but I'm trying to show you the manual way so that you can understand exactly what's going on. Okay, so the client is going to run. We're going to generate Kubernetes YAML. If we ran it up to this point, that would just start the tunnel right now on our machine, but we're exposing via services inside Kubernetes, and therefore we need to run this inside Kubernetes. There's our inlets client. And we're going to apply it. Next up, we could look for the logs. We got deploy twice. And we can see that it is actually connected, and it understands that it's got two upstreams. It's got the Grafana upstream and the Keycloak one. So we could just see if there's anything else here. It says go ahead and access it now. Okay. There's Grafana. Grafana inlets. I believe for that we want to run arcade info Grafana. Get the password. Actually, by the time this is uploaded, this should be down, so don't worry if you've seen any tokens or anything like that. There's no data here yet, but if you had some data you want to connect to, we've got a fully working Grafana on the internet directly from our machine. As for the Keycloak token, what did we call that? Keycloak password, I think. Let's give that a try. Again, it's admin and then the password. We're in. Good. We can go create client. Create one for, I don't know, OpenVAS OIDC. It's just working. So in a very short period of time, we created this inlets tunnel server. We did it manually. We can use automation to do that as well. We then constructed the inlets client command. We generated YAML for it. We deployed it. We can see the client here. We can go look at the logs of it. If we were to somehow lose it, let's say this was on our laptop with Kind on it, we shut Docker down. If you go to a cafe or a Wi-Fi hotspot, a hotel, you open Kind again, it will reconnect and your two domains will be available again. There are other things you can do with inlets. You can also install an ingress controller and expose that. So rather than having each certificate obtained on the EC2 instance, you just have them obtained directly within the local cluster. And then just like we've done here, we could go ahead and create multiple tunnel servers and expose multiple clusters and services from within them in the same way. So if you've got any questions about this, there's a contact form on inlets.dev, or you can go and sign up, try the tutorial, and let us know what you think of it.